All right, let's dive into one of the coolest, most practical ideas in AI today, Retrieval-Augmented Generation. Now that's a mouthful, so we just call it RAG. And the easiest way to get it, just imagine giving your AI an open book exam. Instead of forcing it to recall everything from memory, you let it look up the answers first.
So you've probably had this happen, right? You ask your super advanced AI assistant a question, and the answer you get is, well, it's just plain wrong. Or maybe it's an expert on the year 2021, but it has absolutely no idea what happened yesterday. It's a super common issue, and it really points to a big fundamental crack in how these models work.
Now, before we can really appreciate the solution, we've got to get a handle on the problem itself. So let's take a quick look at the main weaknesses that even the biggest, most powerful large language models, or LLMs, are dealing with straight out of the gate.
Okay, so standard LLMs hit 4 major roadblocks. First, they know nothing about your private stuff, your company's internal reports, your personal notes, none of it. Second, their knowledge is basically frozen in time. They have a hard knowledge cutoff date. Third, and this is a big one, they can hallucinate, which is really just a nice way of saying they confidently make things up. And finally, getting them updated with new info means a hugely expensive and time-consuming retraining process.
So, what's the fix? I mean, we can't just keep retraining these massive models every week. The real answer is in a much smarter design, a new kind of architecture called RAG that actually combines the strengths of a couple of different technologies.
So what exactly is RAG? Well, at its core, it's an AI system that doesn't just rely on what it's already memorized. Instead, before it even tries to answer you, it goes and retrieves relevant information from an outside knowledge source. It literally gets to look things up, just like you would during an open book test.
You know, the whole concept is actually really simple, but it's incredibly powerful. You take the amazing reasoning and language skills of a top-tier LLM, and you pair it with the factual, totally up-to-date knowledge that's sitting in a database. It really is the best of both worlds, a brilliant mind with a perfect, searchable memory.
And what's so great is that this approach gives us a direct fix for every single one of those problems we just talked about. RAG can use your private data because you just point it to your database. It blows past the knowledge cutoff because it's pulling in fresh info in real time. It cuts down on hallucinations big time because it has to base its answer on the facts it just found. And you totally avoid that costly retraining. You just update the database. Easy.
Okay, so we know what RAG does. That's the big picture. But how does it actually work under the hood? Let's walk through the entire pipeline step by step to see how a simple question gets turned into a fact-checked, super accurate answer.
The whole thing really boils down to these 5 stages. First, we ingest the data. Then, we index it so we can search it in a flash. When a question comes in, we retrieve the right facts, augment the AI's prompt with those facts, and finally, we generate the answer. Sounds a little abstract, so let's make it real with a concrete example.
Let's pretend we're building a chatbot for a company. Its job? To help employees answer questions about HR policies. Now, this is a perfect use case for RAG, right? The information is very specific, it's private to the company, and the answers have to be 100% accurate. No room for error.
So the first couple of steps are all about prep work. We take all of our source materials, PDFs, Word docs, whatever we have, and we load them into the system. But here's the key. We don't just dump them in as giant files. We break them down into much smaller, more manageable pieces, which we call chunks. This is so important for finding the exact right piece of info later. Okay, now this is where the really clever part comes in. Every single one of those text chunks gets converted into a long list of numbers. It's called a vector embedding. Just think of it like a coordinate on a giant map of meaning. Things with similar meanings, like vacation time and annual leave, end up really close to each other on this map. This lets our system search for concepts, not just simple keywords. All these embeddings get stored in a special vector database, all primed and ready to be searched.
All right, now a user comes along with a pretty standard question for any HR department. And as soon as they hit enter, our RAG system is about to spring into action.
The first thing the system does is take that question and, you guessed it, it also turns it into a vector embedding. Then it zips through that entire database to find the text chunks that are the closest match on that map of meaning. This is the retrieval part of Retrieval-Augmented Generation. It's the search. And look at what it finds. The system pulls out the most relevant snippets from that huge HR manual. And notice, it didn't just find one thing, it found 2 key pieces of evidence: the exact number of days and that important clarification about public holidays. This is the raw data it's going to work with.
Now for the magic trick.
The system takes these facts it just retrieved and stuffs them directly into the prompt it's about to send to the large language model. It's basically saying, hey, answer this user's question, but listen, you must use only the information I'm giving you right now.
And there you have it. The LLM, now armed with the actual correct facts, generates a perfect, accurate, and complete answer. See how it combined those two separate chunks into one clear sentence? There was no guessing, no making things up, just the facts, straight from the source.
That HR example is great for understanding the mechanics, but this technology is already out there, being used everywhere. So let's look at a few more really powerful examples of how RAG is changing the game in the real world right now.
Just think about customer support, for instance. Instead of a bot giving you some generic, unhelpful answer, it can actually look up the company's detailed policy docs to explain exactly why your data speeds are being throttled. Or imagine a university assistant that can find the precise rules and deadlines for changing your major, buried deep in some student handbook. And for developers, this is huge. An assistant that can retrieve the very latest API documentation to give you code that actually works, not some outdated example it learned 2 years ago. The possibilities are just endless.
So, as we start to wrap this up, let's just quickly recap why RAG is such a massive deal and what the single most important takeaway from all of this should be.
You know, to really see why RAG is so powerful, it helps to put it side by side with another technique people use called fine-tuning. And when you do, for these kinds of tasks, RAG pretty much wins across the board. It's way cheaper, it can handle new and private information instantly, it gives you much stronger control over those pesky hallucinations, and it's transparent. You can actually see exactly which source was used to generate an answer.
So, if you remember just one thing from today, please let it be this. RAG is like having the raw power of Google search combined with the intelligence of a model like ChatGPT, but aimed securely and precisely at your own data. It's a simple idea, but it totally changes what we can and should expect from AI. The question is no longer just, what does the AI know from memory, but what can we empower it to look up?